All right, welcome back to our videos again. Okay, so we'll be going to the assignment for this week, which is on development, and development is just is something that we kind of use to show what a solid is made of. How do I put it? Maybe you can take a tin of milk for an example. If I cut a tin of milk by the side and I unfold it, I'll just have something like a rectangle. So the development for that tin of milk is actually going to have a rectangular shape. So it's that rectangular shape that is folded up to give us that tin of milk, and then maybe we had circles on top and the bottom. So that's what development is all about. It's just like unfolding a solid to just see what it is made up of. So we've been given this assignment to produce the full size development of what is inside pickup and packer, example 8. Okay, it's an example that has already been done, so we're just redoing it, but it's similar, or should I say the same thing as what is inside this slideshow. So let me just use this slide to explain. Yes, so we are going to be drawing a cylinder that is interpenetrated by another cylinder at an angle. So you see, when you unfold, we have to unfold two different cylinders here, because this is one cylinder, this is another cylinder. So there are two different developments that we're going to do here. So we'll do the development of this, and we'll also do the development of this. The development of this is what comes down here. It's like perpendicular to it or something. That's how you just, or should I say parallel to it? I think it's perpendicular, yes. So you just extend lines like that to get all this. We'll do it now so you see how it actually goes. So it depend the this curve depends on where you actually start cutting it from. So in this case now, the cylinder here was cut at this right part here. So this right part is where this cylinder was cut. That's why when it is opened out, it will give this shape. Had it been it was cut on the left side, this um curve here would actually be centralized here together, but because it's not cut there and it was cut here, this is how it will be when it is unfolded out. So basically it's just like unfolding an object, a solid. That's just what development is about. So and yeah, as he explained also in class, the length of this line is actually going to be pi d, or 2 pi r, which is the circumference of the circle. The circumference of the circle, that is the plan view, or what should I call it? The top of the cylinder. So this the radius of the cylinder, yes, determines the length. uh it is basically like we have a circle, and that circle is unfolded out into a line. So this base circle here, imagine cutting it, and then it's like taking a rubber band and then cutting it at a point and then using it to form a straight line. So that straight line would also have an equivalent length with the circumference of that circle. So let's not talk too much about this and just go straight into AutoCAD and continue with our work. Okay, so start drawing. Pick up and pack. So we'll be going to example 8. Example 8. Coming. Scroll. All right, so we are now at example 8. Yes, so this is example 8 here. You can copy the image and then paste it on our AutoCAD. Okay, so we would reproduce this drawings. So for the cylinder, let's just draw a line of, oh, okay, we would have to reduce the size of this. Okay, uh, so line, switch on your auto mode, works like a T square. So 132, uh, sorry, okay, yes, so let's continue. The length of this part is going to be the diameter of this circle, which is 76. So 76, 132, close. Okay, so this line is 30 degrees and it's actually 40 up. So we can use line. We track up from the midpoint of this line, track up by 40, and then we'll have to draw a line that is 30 degrees. So we come here and use our polar tracking, ensure it's on 30. So since it's on 30, we just have to leave our line there like that. So we can just extend it out like that. So now we can offset this line up and down since we have this point, and the diameter of this is 64, meaning that we can offset it by 32 up and down. So offset 32, take it up and take it down. All right, so that one is done. We can now trace lines down to produce the plan view. Sorry, let me switch on my auto. So it stops giving such problems. 50, uh, 50. Yes. So the diameter of this is 76, meaning that we can draw a line 76. Sorry, trying to find the position. Yes. So I can just draw my circle. All right. Now, we can see that we have this cylinder here that is intersecting with this at an angle here. So the view from the top will be an ellipse for this, but we have that the length from here to from center to center is 86. So we can draw a line 86 from the center here. 86. So we can now use that also. We can now also offset this 2 by 32 to the side, 32 to the side. Yes, so we can now trim. trim. So from here we can then take a line up, sorry, alright, sorry for that. So we can take a line up from here and just place it there. Now we can draw a line that joins this and move it from that point to this point. So that way we can get this. Yes. So we have produced that. So we can also bring these lines to draw our ellipse. Extend. So extend. Yes. So we can now draw our ellipse. Our ellipse will just have this. We use the ellipse center. So specify center, major axis, minor axis. So we have our ellipse here. So let's just highlight what we need. Let's increase the thickness so we see what we are doing actually. Okay, we still have to trim this a little bit. Trim. Alright, so yes. Alright, so let's just extend this also down. Okay, so we have reproduced what we were given. So now we would actually have to produce the interpenetration curve for this cylinder and cylinder that are penetrating each other at an angle. So to do that, we would draw a semicircle. We will draw a semicircle that will be of this radius, the radius of this cylinder. We'll draw it there. Okay. So uh, we we should also draw the same circle here. We can maybe shift it out a little. So extend lines. Yes. So trim. Okay. So we divide both into the same number of divisions. So we can divide both circles. So divide, select object 6. Divide, select object 6. So now we would trace lines from here to touch this place because the interpenetration curve is supposed to reproduce from this part of this cylinder. This is where it's supposed to reproduce. So we project lines now. So copy this. Alright, so we can trim. Alright, so now we trace lines up also. We can maybe use different colors. Uh, let's just use different colors. Let's use different colors. Okay, so we'll use different colors for these lines. So we'll be able to differentiate them clearly. So uh, let's use green. Can maybe leave this one. Leave it also. Yes. So now we would trace lines up. Trace lines up. Okay. So we've traced those lines up. Now we can also change the colors of the lines that we're tracing to the colors of the lines that they are coming from. So this is red. We change also to red. So let's change it to red. Uh, sorry. Alright. So we've changed those lines to red. So let's change the lines for the green to green also. So this will be green. Then we'll leave this to be blue. Okay. So now we will draw lines parallel to this. We'll draw them also straight down. So what we will be doing is just that it will also be the same way we've done these lines. Red, green, blue, green, red. It's the same way we paste lines red, green, blue, green, red also here. So we'll see where each line is actually intersecting. Oh, sorry, we made a mistake. This has to be red. Yes. Okay. So where red is intersecting red, where blue is intersecting blue, where black is intersecting black, that's where we'll use as our points. So now let's go on with it. Can copy this line, paste it all over. So red, red, make it red. Uh, green, green, and this should be blue. Okay. So I think this color coding is even actually wrong, but we'll be able to see what our answer is supposed to be actually in the end. Sorry, I don't think this thing is correct, but I'll correct it when it's necessary. Okay, so yeah, so let's extend all these lines. Line one supposed to meet line one here. Line two supposed to meet I2. This, sorry, sorry. Yes, so the color codes are actually quite wrong, but somehow I think you'll be able to see what I want you to actually see. So this first division, second division, third division, and so on like that. All right. So as I was saying, this is where we will get our interpenetration curve from, like line 0 to 0, line 1 to 1, line 2 to like that. So let's just draw a spline. So that is going to be the interpenetration curve for the cylinders. So we can thicken it. Yes. So we can also thicken this too. Uh, all right. So now, remember we said we have two cylinders here. So this cylinder and this cylinder. So we have to cut them and then open them up to see what is inside them. So let's do this one first. Let's do this cylinder first. So ray, copy this ray line, copy. All right, okay. So we've done that part. Uh, we can copy out this to a point away from there. So we can now use that to start our work. Okay, now remember this length of this place is supposed to be pi d, that is 2 pi r, the circumference of this cylinder. So our circumference is actually here, so that's it in our properties. It is 238.76 millimeters. So we can just copy our line or offset our line by 238.76. So sorry, yes. So this will represent pi d. So let's just trim. Okay. So now we can work here. Okay. Uh, we can work in the middle of this. Let me just make this line not thick yet. Okay. Alright. So now that we have the interconnection curve, we can now start drawing our this thing, our development. But for us to draw our development, we've done our pi d, we've done the circumference. We would actually have to divide this circle into 12 parts. We'll divide it into 12. Now, those 12 parts that we have divided it into, we can maybe label them so that we'll understand where we are cutting it from, how we are going around the cylinder. So, uh, when we finish dividing like that, so okay, so yes, so we can divide like that. So sorry, okay, sorry. Okay, so we divided it and we use this place to be our beginning point. So we have to go around 1, 2, 3, 4, 5, 6 back to 1. So that's how we'll cut it from on the point 1. So we would label, we would have to, let's just outline this part. Change it to, let's outline our 238.76. So divide, we'll divide this line also into 12. Same way we are dividing, same way we are dividing our circle, because our circle is actually this line too. It's just that we have cut this rubber band and we have cut it so it's now a straight line. So same way we've divided this circle, same way we divide this line too. Okay, so we divided the line into 12 segments. Now we can also label the line with 1 to 12. Uh, okay. Oh, sorry. Okay, so we have labeled this 1 to 12 to 1 back. So now that we've labeled it 1 to 12 to 1, we can start cutting and going round. So if you look at it, it is on this point between points 1 to 2 to 3 that we would actually have this curve here. So that means that we'll have our curve here already. So maybe we can just have different colors again. Red, green, blue, yellow, purple, so okay, maybe we'll just use another column. Yeah. All right. So, uh, now that we have this thing called for everything, um, we would actually have to look for points where we'll go from 1 to 2. You see, on this line, when we move from 1 to 2, between 1 and 2, we get to this point here where we transfer the lines for the curve. So, which means between this 1 and 2, we have to have a line that would intersect to give us this curve points on this place where we would actually have this curve shown on this development. So between 1 and 2, we have this point here between 1.1 and point 2. So uh those points 1 and point 2 are the ones that produce this and this. Okay, maybe we should just make this and this the same color. So both will be green. Okay. So now uh what we have to do here, remember we said the same way we divided this line is the same way we divided this line. So we have the same length here, same length here. So we are actually going to have to maybe copy out this circle, copy it somewhere, and just maybe paste multiple copies of this line. Sorry, I forgot to take these lines along with them because they are necessary. These lines are necessary. They are the ones we'll use in selecting what we are doing. So we'll copy them again. Also paste them, paste, paste them everywhere. Yeah. Sorry, let me just move this one out. Yes. Okay. So now remember we said when we are going from point 1 to 2, there is this length here that gives us a point where we can get points on the intersection curve. So we are actually going to trim this and trim this. Sorry, uh, I have to mark the point 1 on the arc. So we'll trim it. Yes. So if you understand what I've been saying since morning, the length of this particular arc, this length is going to give us the distance that we're supposed to move from here between 1 and 2 to give us what we would use to produce the points on these two lines to know where our splines will pass through. So this arc here, all we have to do is press Ctrl 1 and you see all the properties and you come to arc length. So arc length shows us that it is 16.52. You can also use you can right click on it. It should give you properties, not quick properties, full properties. That's what gives you this. So you can see arc length, and the arc length is 16.52. So which means that this line, we can just draw this line, we can offset this line by 16.52. So we'll set it to this side. So this will give us points where it will intersect here. So this line, this line, this line intersects this line here and here. So this particular point here, this particular point here, it has been shown where to intersect. So maybe we can also make this also a green line, so we know green, 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 those are the points. Okay, so when we have gone from 1 to this point, and this point we can go to 2 because we have gone 1 to the point to 2. So now moving on from 2, we get to this red line point. So on the red line point, we can, that means we are moving from 2 to 3 this time around. So between 2 and 3, there's this point with the red line. So let us find the arc length for that point now. So let me move this. Sorry. Okay. So we'll be making a point also here just to mark it. So trim here, and you also trim here. Yes. So this is the arc that we need. So we can also right click here, check properties, see the arc length. It is 11.16 away from 2. So we can now come here. We should have actually pasted this line everywhere. 1, 2, 3, 4. Yes. So now that we have checked the arc length of that one, we can offset by 11.16. 11.16 to this side. So this line is for the red. So we can make the red line, red line, red line. So the red line touches it here and also touches it here. So we can make everything red. So it intersects on this point and this point too. Okay, so we have actually gone from 1 to 2 to 3 that way. So we have marked our points 1, 2 to 3. So now this is the thing. The curve is going to go like this. It will start from here to where green and green are meeting, go through to the red and red, and the center point there is on the oh sorry, we have to still mark, we have to mark this point because this point is different from this point. Sorry about that. So we would have to take another copy, but we would have to include this line on it. So yes, so this small arc here, we have to know the length also. So trim and trim also. So this arc is what we want to know. So the length of this arc is 1.75. 1.75. All right, so that is 1.75 away from 3. 1.75 before 3. From 2 to 3. So 3 backwards, 1.75. That's where the spline stops. 1.75. Enter. Yes. So we can make this line yellow. This can also be yellow. So now let's draw our spline. So our spline starts from here, because this is the beginning point. Starts from here, goes through to where green and green intersect, goes through to where red and red intersect, goes to where yellow and yellow intersect, then red and red back again, then green again, then back to the end. Oh, sorry. Let me just make this a black one. Yeah, so we were going from point to point. Yes. Yes, and there. Enter. Sorry. Yes. Okay. So, this way we have gotten our development for this part of this thing. So we can just mirror it because it's the same thing on the other side. So we can mirror it to that side, and then now we can just outline where we are going. Yes. And okay, and this is done for this one. So we have the development for this particular cylinder. So we can now do this development for this part of the cylinder, this second cylinder. So the second cylinder would have its own, it will have its own projections like this. So let's just, we copy this line again, same way we copy those other lines the other time. Copy it and you paste it on every point like that, like that, like that, and like that. So yes. So now that we have copied and pasted it all over like that, we can now open it up. This one is a straight thing to do because doesn't really have any problems. We can just calculate the pi d again. So the pi d would be the circumference of this circle, which is 201.06. 201.06. So let's just copy a line forward. We use this line, copy it, and use it to cut the line somewhere there. So make it black. Okay, so now we can offset this by 201.06. Yes, so we can now trim, 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 and trim. Okay, So now that we have those, we can divide this line also. Divide, divide. So to divide it into 12 parts. So we can paste this line all over again. Okay. Uh, I like to make this midpoint line a different color so I can always identify the midpoint. Okay, so uh, if you look at it carefully, you'll see that this point to this point to this point to this point, they're like this. But here there's a curve. When you open it up, when you slice it like this at this place and you open it up, so uh, using that, we can now start looking one by one from this point. So we go from this point to this point. So one by one we move to this, to this, to this. You have to be careful here. You see that this line is different from this line. So this will be the first point. Let's just draw our spline. So this is the first point. This will be the second point because this is the second point. The third point is here, is on this line. Now for the fourth point will be the next point after this part, which will be this line, the one on top here. We should have changed colors actually, so we'll be able to identify them easily. So it will be the fourth one on top here. Then after the one on top there comes to this one. So this one is the next one. So after the highest point comes to this one. This one is under. Okay, so it's the third line. So okay. So after that, where does it go next? It ends on this line. Okay, which is the fourth line. So we can just also mirror this also about this axis, and we have our development for the full question. So the question is answered.